It's incredible to think that, after the dinosaurs, new apex predators rose to fill the void. Among them, the terror birds. And what's even more amazing is that one of these terror birds, unlike its relatives, actually colonized Europe. It remains the only known terror bird to have lived outside the Americas. These feathered nightmares emerged from the ashes of the dinosaur extinction, proving that nature abhors a vacuum, especially when it comes to apex predators. Roughly 53 million years ago, in the early Eocene, the world was a very different place. It was a hothouse with lush forests stretching from pole to pole, filled with a diverse range of life forms that emerged after the dinosaurs' extinction. It was in this steamy prehistoric paradise that the first terror bird, Paleopsilopterus, made its debut. Standing at a modest height of 1 meter, or about 3 feet, this Brazilian bird might not have seemed particularly terrifying at first glance. In fact, it was about the same size as a modern-day stork. Hardly the stuff of nightmares. But appearances can be deceiving, and Paleopsilopterus had something its contemporaries lacked: potential. What set Paleopsilopterus apart was its agility and speed, traits that would become hallmarks of its descendants. While it may not have been the apex predator of its time, perhaps dwarfed by monstrous crocodilians and giant snakes, it was a harbinger of things to come. As we step into the Miocene and Pliocene epochs, spanning from about 23 to 2.5 million years ago, we encounter the true giants of the terror bird family. These were creatures that pushed the boundaries of what it meant to be a bird, reaching sizes that rivaled the predatory dinosaurs of old. 3 names stand out in this pantheon of avian terrors: Titanis, Kelenken, and Eluthaornis. Each of these genera represents the pinnacle of the terror bird lineage, and each had its own claim to fame. Titanis, the youngest and smallest of the trio, was also the most adventurous. While most terror birds were content to dominate South America, Titanis had grander ambitions. It crossed the newly formed land bridge connecting North and South America during the Great American Interchange, becoming the only large South American predator to successfully establish itself in North America. Unlike most of its relatives, this bird lived in what is now the United States, including the states of Texas, Florida, and California. Standing 2 meters, or 6.6 feet tall, Titanis would have been an imposing sight for the mammals of North America. Imagine the shock of a Pleistocene horse or ground sloth, accustomed to watching out for saber-toothed cats and dire wolves, suddenly confronted by this alien predator, half bird, half nightmare. But as impressive as Titanis was, it was dwarfed by its cousins back in South America. As for their hearing, the inner ear structure of terror birds suggests an acute sensitivity to low-frequency sounds. This ability would have allowed them to detect the footsteps and movements of potential prey, even when hidden by dense vegetation. I imagine a terror bird standing motionless in the prehistoric forests of South America, its head cocked slightly to one side. To a casual observer, it might appear to be resting or even dozing, but in reality, every fiber of its being is alert, its incredibly sensitive ears picking up the faintest rustle of leaves or the softest patter of tiny feet. In an instant, it can pinpoint the location of its unsuspecting prey and launch into action. This combination of visual and auditory prowess made terror birds the complete predatory package. It's no wonder these birds were able to dominate their ecosystems for millions of years. But even the mightiest rulers faced their downfall, and the reign of the terror birds was no exception. For millions of years, these avian predators had ruled supreme in South America, developing into a diverse array of species that filled various ecological niches. But somewhere along the line, their luck ran out. Traditionally, the extinction of the terror birds was linked to the Great American Interchange, a major paleozoographic event that occurred about 2.7 million years ago. This event saw the formation of the Isthmus of Panama, creating a land bridge between North and South America. In contrast, as a solitary hunter, it would have been quite difficult for the Nandong tiger to match that intensity when attacking prey. This factor placed it at a disadvantage in the competition for apex predator status. However, that was not the only thing the Nandong tiger had to worry about when defending the apex predator title. Around this time, early humans were notably prevalent in Southeast Asia, as over 80 individual remains have been found in that region today. So it's likely that they would have crossed paths with the Nandong tiger. It is easy to say that such encounters would have been unfavorable for the early humans, because when it comes to size, they stood very little chance against such predators. But saying that would be undermining their intelligence. Over time, early humans might have developed tools and strategies to fight back against the Nandong tiger, forcing the tigers back to the open woodlands, and allowing early humans to establish a foothold in the region. The open woodlands of Sunderland in the Pleistocene epoch had numerous scattered trees and grasslands, which provided good visibility for stalking prey and offered a diverse array of herbivores, including many large species. However, hunting larger herbivores may not have been that successful despite the Nandong's enormous size. For instance, stegodons were massive proboscideans closely related to elephants, with some species reaching immense sizes. These included periods of intense cold, with vast ice sheets locking up water leading to lower sea levels, followed by warmer periods with melting glaciers and rising sea levels. As a result of this, Sunderland was fragmented into smaller islands, leading to the isolated populations of Nandong tigers, with limited resources and genetic diversity. From these isolated populations emerged smaller subspecies of tigers, such as the Sumatran tiger, Bali tiger, and Javan tiger. While climate change undoubtedly played a role, scientists proposed that the presence of early humans in Southeast Asia might have been among the reasons why the tigers went extinct. They likely caused increased competition for resources or potential conflicts that impacted the Nandong tiger population. Other factors may have also contributed to their demise. But with limited fossil records, we are left with many unanswered questions. There was a cat, not too long ago, just a blink of an eye in Earth's timeline, that I find myself constantly drawn back to. It wasn't just any big cat. It was the undisputed monarch of the Ice Age, Smilodon, the saber-toothed cat extraordinaire. It's strange, isn't it? That an animal so lethal, so perfectly adapted to its environment, could vanish entirely. When the first Smilodon remains were unearthed in Brazil about 160 years ago, paleontologists didn't immediately recognize them as belonging to a cat. In fact, their initial guess was way off the mark. Based on some isolated cheek teeth that bore an uncanny resemblance to those of modern hyenas, they dubbed this new find hyena Neoga. However, within a couple of years, the tides of discovery brought forth a tsunami of new fossils. Suddenly, scientists weren't just looking at a few teeth, but a veritable jigsaw puzzle of prehistoric proportions. Foot bones, skull fragments, and those iconic canines, which, by the way, seemed almost comically oversized for any mouth, painted a very different picture. As the pieces fell into place, it became clear that this was no hyena. Instead, they were dealing with a completely new genus of felid, one that was not only massive in size, but also built like a prehistoric tank. This feline was far more robust than any modern cat, a true heavyweight champion of the Ice Age. In light of this revelation, a new name was in order. Thus, Smilodon populator was born. Smilodon meaning knife tooth, and populator roughly translating to the destroyer, or he who brings devastation. With its new identity established, the scientific community dove headfirst into unraveling the Smilodon's family tree. This quest for understanding continues to this day, with researchers currently placing our knife-toothed friend in the extinct Suba F family, Machaerodontinae. This Suba F family is home to most of what we colloquially call saber-toothed tigers. Though saber-toothed cats is more accurate, since these ancient felines aren't closely related to modern tigers, or any living cats for that matter. In fact, their closest living relatives might be members of the Felinae Subae family, which includes our domestic kitties. Within the Machaerodontinae, Smilodon found itself in an even more exclusive club, the Smilodontini, or, as some paleontologists like to call them, the dirk-toothed cats. This group is pretty exclusive, with only 5 known genera calling it home. But what Smilodontini lacks in diversity, it makes up for in star power thanks to Smilodon. As research progressed, scientists discovered that Smilodon wasn't a lone standout. It was more like a prehistoric trio with 3 distinct members, each bringing something unique to the table: S. gracilis, S. fatalis, and S. populator. S. gracilis appeared in North America about 2.5 million years ago, descending from an even older genus called Meganterion. Next came S. fatalis, strutting onto the scene roughly 1 million years later. Last, but certainly not least, S. populator made its grand entrance about 600,000 years after fatalis. S. gracilis, while no slouch in the size department, was the runt of the litter, tipping the scales at about the same weight as a modern jaguar. S. fatalis, living up to its name, was a step up in the terror department, matching an African lion in size, but packing on extra muscle like a feline bodybuilder. We're talking about 280 kilos, or 620 lb of prehistoric fury. That's on par with the largest tigers roaming the earth today. But S. populator dominated them all. This behemoth pushed the boundaries of felid physiology, with the largest known specimens estimated to have weighed in at a jaw-dropping 470 kilos, or 1,040 lb. To put that in perspective, that's about the same as a medium-sized polar bear. Interestingly, unlike many modern big cats, Smilodons didn't seem to be too hung up on gender norms. Studies suggest that there wasn't a significant size difference between males and females, a trait scientists call low sexual dimorphism. In practical terms, this means that regardless of whether you were facing a male Smilodon or a female Smilodon, you were in for equally big trouble. Now, being big is impressive, but Smilodon wasn't just large. It was built like a prehistoric tank. The Smilodon's heel bone was a marvel of natural engineering, robust and elongated. In fact, some paleontologists speculate that these Ice Age acrobats could have outjumped modern lions, which have been observed clearing heights of 15 ft or 4.5 min. Imagine a cat the size of a bear, capable of leaping over a one-story building. But the Smilodon's athletic prowess didn't stop at its fancy footwork. If modern big cats have arms that could crush you, Smilodon's forelimbs took it to the next level. We're talking about limbs that were approximately 20% thicker than what you'd expect for a cat of its size, giving it incredible strength, surpassing even that of the larger American lion. And at the end of those muscular arms, Smilodon was further armed with fully retractable claws, razor-sharp and curved like prehistoric sims. They were proportionally enormous, even for a cat of Smilodon size. We're talking about claws twice the size of a Siberian tiger. Those saber teeth, they've captured imaginations for generations. I've always been fascinated by them. Smilodon perfected the saber tooth, taking the concept to an entirely new level. It wasn't just their presence, but their sheer audacious length. We're talking about canines so long, they protruded well beyond the lower jaw, a feature that was uncommon even among other saber-toothed cats. Smilodon's canines could grow up to 8 inches long, longer than many modern kitchen knives. They were precision instruments of prehistoric destruction, shaped like deadly daggers with sharp points and smooth, narrow sides, designed to pierce deep into flesh with devastating efficiency. What's really interesting is that you'd expect a predator with teeth like that to have a powerful bite to match. But studies have shown that Smilodon's bite was relatively weak, about 1,000 newtons, which is 4 times weaker than a modern lion's. How did it kill? One popular theory suggests that Smilodon was the original ambush predator. I picture one hidden in dense vegetation, waiting for the perfect moment. With a powerful leap, it pounces on its unsuspecting prey. Using those muscular forelimbs and grappling hook claws, it pins down its victim, then sinks its saber teeth into the prey's soft underbelly, causing massive internal damage and blood loss. But many researchers favor a different scenario. They propose that Smilodon used its powerful build to quickly overpower its prey, then delivered a precise lethal bite to the throat. This would have caused severe blood loss and suffocation. Adding fuel to this theory is the discovery that Smilodon could open its jaw to an incredible 120 degrees, almost twice as wide as a human can manage. With a gape like that, pretty much every neck in the Ice Age would have been fair game. Brain scans of Smilodon skulls suggest that these prehistoric predators had excellent coordination, sharp hearing, and top-notch vision. Their eye socket shape hints at binocular vision, giving them the depth perception needed to judge distances accurately, crucial for a predator that relied on ambush tactics. And they were fast, too. Many Smilodon fossils show trauma to their sternums, the kind of injury you'd expect from high-speed collisions. Smilodon's traits, along with its weaponry, made it a versatile hunter capable of taking down a wide variety of megaponal prey. In North America, their prey included giant bison, camels, and even mastodons and Columbian mammoths. After all, those saber-like fangs seem like they would have been quite the obstacle during feeding. Smilodon had a solution for that too. Unlike most predators that can chomp down from the front, Smilodon was equipped with specialized slicing teeth called carnassials. These teeth, situated on the sides of the mouth, worked like biological scissors, shearing through meat with ease. To eat, Smilodon would have turned its head to the side, using these carnassials to slice off manageable chunks of meat, while its saber teeth stayed out of the way. If this eating style sounds familiar, that's because you might have seen it in action. Many modern cats and even other predators use a similar technique when tackling tough pieces of meat. It's a prime example of nature's problem solving. When life gives you saber teeth, you adapt your eating style accordingly. With its unique adaptations and hunting prowess, Smilodon carved out a vast empire for itself. Between its three species, it achieved a distribution across the Western Hemisphere that would make any modern predator green with envy. In North America, Israelis and Asphatulus roamed from coast to coast, reaching as far north as Alberta, Canada. Meanwhile, in South America, Asphatulus and Aspopulator established a domain stretching all the way down to Patagonia. Smilodon wasn't just geographically widespread, it was also adaptable. Specialized in taking down giants, it struggled to adapt to a world where those giants were disappearing. It was, in essence, too good at what it did, and when the world changed, it couldn't change with it. The extinction of Smilodon marked not just the end of a species, but the end of an era. It was the last of the saber-toothed cats, not just in the Americas, but worldwide. With its passing, a lineage that had dominated the planet for over 20 million years came to an end. Its legacy, however, still resonates in museum exhibits, in our imaginations, and as a reminder of the fragile balance between species and their environments. As we face our own period of rapid change, the lesson of Smilodon is clear. Survival requires adaptation. Most apex predators face a fundamental limitation. They're trapped in one environment. Lions rule the savanna, but are helpless in water. Great whites dominate the ocean, but can't set a fin on land. Even T-Rex, for all its might, was confined to dry ground, forced to watch as prey slipped into rivers and lakes beyond its reach. For over a century, paleontologists assumed the greatest hunters were strictly terrestrial. Then, one discovery shattered that belief overnight. Its name was Spinosaurus aegyptiacus. Longer than a bus, armed with the skull of a crocodile and the body of a streamlined aquatic hunter, this was no ordinary killer. This was the nightmare that redefined what it meant to be an apex predator. A monster that could rival, and in many ways surpass, even T-Rex itself. The first thing that truly unsettles you about Spinosaurus isn't just its length, though at 50 to 59 feet, or 15 to 18 meters, it dwarfs even the largest T-Rex specimens. It's not even the massive sail rising from its back, like some prehistoric fin. No, it's how perfectly wrong everything about this creature appears, and yet how devastatingly effective each bizarre feature proved to be. Take that skull, for example. A narrow, elongated nightmare stretching nearly 6 feet long. If you've ever stared into the eyes of a large crocodile, you understand the primal fear that comes from seeing a predator perfectly designed for aquatic ambush. Now, imagine that same sinister profile scaled up to dwarf any modern crocodilian, mounted on a body that could rear up 20 feet into the air. The skull alone weighed as much as a small car, yet it cut through water with the efficiency of a torpedo. Those jaws housed over 60 interlocking teeth, each one a curved, needle-sharp instrument of death designed for one purpose: gripping slippery, struggling prey underwater. Unlike the bone-crushing teeth of T-Rex, built for delivering massive bite forces to terrestrial victims, Spinosaurus's teeth were fishing spears made of enamel. Once those jaws clamped down on a 15-foot sawfish or massive lungfish, escape became physically impossible. But the skull was just the beginning of this creature's aquatic arsenal. Where other theropods developed powerful legs for running down prey across land, Spinosaurus rewired its body for a different kill zone. Its toes were webbed, its legs positioned differently, its entire lower body redesigned for propulsion through water rather than speed across terrain. For anything living in those rivers, the nightmare was the same: the faint ripple at the surface, the sudden silence, and then the 7-ton shadow sliding in after you. And while most large theropods had relatively small forelimbs, Spinosaurus possessed powerful, elongated arms ending in massive claws. These weren't vestigial appendages. They were additional weapons, perfectly positioned for grabbing prey, maintaining balance in water, or delivering killing blows. The creature could literally embrace its victims to death. And then there's the sail, rising up to 7 feet above its spine. This massive dorsal fin dominated Spinosaurus's silhouette like the warning flag of death itself. Scientists debate its exact function: thermoregulation, display, fat storage for surviving dry seasons. But its psychological impact is undeniable. Picture this nightmare rising from murky water. First, the elongated snout breaking the surface. Then, those cold reptilian eyes. And finally, that towering sail cutting through the air like the dorsal fin of some impossible shark. The idea that Spinosaurus transformed every waterway it entered into its personal killing field. It's a chilling thought that has stayed with me. Imagine the terror of being a fish in those ancient rivers. Creatures had evolved to recognize danger: shadows, ripples, subtle currents. But Spinosaurus rendered all those instincts useless. The attack could begin before you even knew you were being hunted. Those paddle-like feet weren't just for show. They propelled Spinosaurus through water with surprising speed, allowing it to pursue prey through underwater mazes, where other large predators would become trapped. Unlike purely aquatic predators, or those limited to shoreline attacks, Spinosaurus could adapt its hunting strategy in real time. If it missed underwater, it could simply rise to the surface and snatch prey from above. And the intelligence of this creature. Crocodiles are clever, but operate largely on instinct. Spinosaurus possessed problem-solving capabilities, cognitive tools that made other theropods effective pack hunters. But this intelligence was applied to an environment where most prey had never faced anything remotely similar. Even the act of drinking water became a death trap. For millions of years, animals had taken a calculated risk approaching rivers and lakes. Stay alert, drink quickly, watch for crocodiles. But now the riverbank itself became unreliable. That submerged log might be a 50-foot predator. The creature could track multiple targets simultaneously, predict their movements, and position itself for killing strikes with mechanical precision. Those massive nostrils, positioned high on the skull like a crocodile's, allowed Spinosaurus to breathe while almost fully submerged, keeping most of its body hidden beneath the surface. Its snout was covered in a dense network of tiny sensory pits specialized for detecting press waves and subtle water disturbances. In murky rivers where visibility dropped 2 inches, this system worked like underwater radar. The death of a Spinosaurus roughly 94 million years ago didn't end its story. The questions it raises about survival continue to ripple through our scientific understanding. Like press waves from some impossible prehistoric nightmare that refuses to stay buried. I often think about how Spinosaurus hunted. It could sense prey long before it saw it. Unlike land predators, which had to worry about prey escaping in all directions, Spinosaurus used the water as a weapon. Its powerful arms and webbed feet created underwater currents that disoriented prey. Its massive size displaced enough water to generate press waves that stunned smaller fish. The final strike must have been terrifying. This predator combined the bone-crushing power of the largest land carnivores with the precision of the most effective aquatic hunters. The bite, while not as strong as a T-Rex's, was perfectly calibrated. The climate was so warm that palm trees grew at what we now consider Arctic latitudes, and so humid that massive thunderstorms rolled across the landscape with mechanical regularity, feeding the endless network of rivers and swamps. And in this steaming, river-choked ecosystem, Spinosaurus was far from alone. The Kelenken formation reveals that this aquatic terror shared its territory with a deadly mix of predators, prey, and rivals. Giants like Carcharodontosaurus patrolled the inland areas, while Sarcosuchus, the 40-foot super croc, competed with Spinosaurus for aquatic hunting grounds. Mid-sized hunters like Rugops cleaned up Spinosaurus's leftovers, while swift predators like Deltadromeus and Bahariosaurus used speed and specialized tactics to carve out their place. Herbivores like Ouranosaurus, Ribacosaurus, and the colossal Paralititan somehow survived this gauntlet. The waters were filled with monstrous prey like Onchopristis, Morsonia, and lungfish. Every species lived in constant tension with Spinosaurus's dominance. Land predators maintained uneasy truces. Herbivores relied on elaborate survival tactics just to drink. And aquatic prey developed increasingly tough defenses. The skull was unlike anything I'd seen before. It had these specialized enlarged premolars and this incredibly strong cranial structure. It reminded me more of a lion or a hyena than any dog I knew. It posed a real challenge. What exactly was this creature? The answer, as it often does, lay in the details. Those specialized premolars and that robust jaw pointed to the Borophagini subfamily, a unique and, in many ways, little-known branch of the canid family. They were successful too, incredibly diverse, with 66 known species. The Borophaginae had powerful teeth, short but deep jaws, and a fifth toe, something most modern canids have lost. For over 15 million years, they dominated North America. Some were fox-sized, others rivaled today's grey wolves. And then there was Epicyon, the ultimate bone-crushing dog. Its name literally means more than a dog. Recent studies of modern canids are helping us understand where Epicyon fits in the larger family tree. It seems the Borophaginae were a highly specialized branch, taking a different evolutionary path than the one that led to modern wolves and dogs. This specialization explains both Epicyon's unusual features and, perhaps, its eventual extinction. Within the Epicyon genus, 3 distinct species emerged: Epicyon savus, Epicyon haydeni, and Epicyon elodontoides. They each filled different ecological niches, varying in size and build. The smaller species, savus and elodontoides, were more gracile, built for speed and agility, though still formidable. Even these smaller species weighed twice as much as a modern German shepherd. But it was Epicyon haydeni that truly pushed the boundaries. Recent studies have revealed just how massive they were. Adults routinely reached lengths of 2.4 meters, nearly 8 feet, about the size of a grizzly bear. They stood 90 centimeters, or 35 inches, at the shoulder, like a wild deer, and they weighed between 125 and 170 kilograms, 275 to almost 375 pounds, heavier than modern leopards, and comparable to large jaguars or even a medium-sized male lion. That would have made them the heaviest canids ever to walk the earth. Size alone made Epicyon a formidable predator, but its most remarkable feature was its bite. Biomechanical studies have revealed it possessed one of the most powerful biting mechanisms ever seen in a mammalian carnivore. The enlarged premolars, the strategically positioned canine teeth, closer to the jaw joint than in modern canids, created a highly efficient biting machine. New analysis suggests Epicyon's bite force may have exceeded 16,000 newtons, comparable to a large American alligator. The closer placement of the canines to the jaw joint created a more efficient lever system, concentrating enormous force at the tooth tips. It was a bite that could easily pierce through thick hide, flesh, and even bone. Microscopic analysis of wear patterns on preserved teeth provides direct evidence of how Epicyon used its formidable bite. The patterns are consistent with both flesh slicing and bone crushing, suggesting a predator that could efficiently process every part of its prey. Fossil deposits indicate that Epicyon was an opportunistic predator, capable of taking down a wide range of prey, including ancient camels, pronghorns, horses, and peccaries. Most impressively, they seem to have been capable of hunting prehistoric rhinoceros species like Teleoceras, which could reach lengths of 4 meters and weigh nearly 2 tons. Studies suggest that Epicyon may have employed different hunting strategies depending on prey size and availability. For smaller prey, they likely hunted alone or in pairs, using their impressive speed and power. However, evidence increasingly points to the possibility that they also engaged in pack hunting, particularly when targeting larger prey. This idea is supported by the social behavior of nearly all well-studied modern canids, most of which show higher levels of sociality than the average mammal. The fossil record also provides further support. I've always been fascinated by the stories fossils can tell, especially when what we thought we knew. Take Epicyon, for instance. It wasn't the tallest, fastest, or most fearsome predator of its time, yet its fossils tell a story of survival that defies expectations. It wasn't dodging T-Rexes, but it was thriving in a world of its own challenges. What really strikes me is how abundant Epicyon remains are in North American deposits. It's a pattern you usually see with social predators, which suggests these creatures weren't solitary hunters. It allowed them to extract maximum nutrition from their kills by accessing bone marrow, one of the most nutrient-rich tissues available to carnivores. It also potentially reduced competitions with other predators by allowing them to utilize parts of carcasses that other carnivores couldn't process. The ability to process bone would have been particularly valuable during times of scarcity. The Miocene epoch, you see, was characterized by significant climate fluctuations, with periods of warming and cooling, and shifts between wet and dry conditions. During times when prey was scarce, being able to fully utilize every part of a carcass, including the bones, would have provided a crucial survival advantage. The success of Epicyon is clear from its widespread distribution across North America during the Miocene. Fossil remains have been discovered in more than 10 different US states and parts of southern Canada, which indicates a remarkable ability to adapt to various environments. These ancient predators thrived in a diverse array of habitats, from woodlands and savannas to grasslands and wetlands. The discoveries of Epicyon remains in cave systems and edge environments are particularly interesting. These findings suggest that Epicyon wasn't only adaptable, but potentially strategic in its habitat selection, preferring areas that provided both hunting opportunities and shelter. Their ability to process a variety of foods likely contributed to this ecological flexibility. While primarily carnivorous, the structure of their teeth suggests they could also process tough plant material when necessary. This dietary flexibility, combined with their bone-crushing abilities, would have allowed them to survive in a wide range of environments and through various seasonal changes. The ultimate disappearance of Epicyon from the fossil record has long intrigued paleontologists. Early theories suggested that competition from newly arriving big cats led to their extinction. But this hypothesis has largely been discounted, as many of the large cats that would have competed with Epicyon, like the saber-toothed cat, didn't appear in North America until millions of years after Epicyon's disappearance. Current evidence points to climate change as the primary driver of Epicyon's extinction. The late Miocene saw significant global cooling and increased aridity, leading to fundamental changes in North American ecosystems. Paleobotanical studies indicate a shift from mixed woodland savanna environments to more open grasslands. This transformation would have affected not only the types of prey available, but also hunting strategies. Epicyon specialized adaptations. Its heavy build, bone-crushing teeth, and relatively short legs may have become disadvantageous as prey species became faster and more adapted to open environments. Unlike their more generalized relatives, which gave rise to modern wolves and other canids, Epicean's extreme specializations may have limited its ability to cope with these changing conditions. The discovery of Ankylosaurus magniventris wasn't just a milestone for paleontology. It opened a window into the intricate design of one of nature's most formidable creatures. Imagine a biological tank, meticulously designed for strength and survival. This creature presented such a unique combination of features, it demanded its own taxonomic family. The name itself tells part of the story. Ankylosaurus, meaning fuse lizard, a reference to its remarkably fortified skeleton, while magniventris translates to great belly, highlighting its distinctively broad midsection. In 1906, I remember reading about how Barnum Brown of the American Museum of Natural History led an expedition through Montana's Hell Creek Formation. Among the layers of Cretaceous sediment, Brown unearthed an assortment of fossils that perplexed him at first glance. These weren't the slender, elongated bones of theropods or the broad frills of ceratopsians. Instead, he had uncovered fragments of bony plates, uniquely shaped teeth, and vertebrae that hinted at a heavily armored animal. Early interpretations were cautious. Brown initially speculated that the bones might belong to a previously unknown type of armored dinosaur. Over time, further excavations in Canada and the western United States revealed more specimens, each shedding light on the creature's physical characteristics. The painstaking process of piecing together its skeletal framework was akin to assembling a prehistoric jigsaw puzzle, with every discovery adding a layer of complexity to its story. What made Ankylosaurus magniventris stand out was not only its robust anatomy, but also its ecological implications. Fossils of Ankylosaurus were found in association with remains of plants, indicating the lush environments it inhabited. Over the decades, advances in paleontological techniques, including CT scanning and isotope analysis, have allowed scientists to reconstruct its appearance and understand its lifestyle in remarkable detail. From the armored plates that defined its body to the distinctive club at the end of its tail, Ankylosaurus stood as a creature that epitomized nature's ingenuity. What made this discovery particularly groundbreaking was that it didn't just represent a new species. It became the cornerstone of an entirely new group of dinosaurs, the Ankylosauria. These animals, belonging to the larger clade Ornithischia, were characterized by their extensive armor plating and herbivorous lifestyle. Within this group, Ankylosaurus belonged to a more specialized family, the Ankylosaurids, distinguished by their massive triangular skulls, stocky builds, and elaborate defensive features. But among all its relatives, Ankylosaurus held a special distinction. It was the largest of its kind ever discovered, with adults reaching lengths between 5.4 to 10 meters, or 17 to 33 feet, and standing about 1.7 meters at the hip. More impressively, these titans weighed between 5 and 8 tons, surpassing even the famously robust Triceratops in mass and rivaling the earlier aquatic predator Spinosaurus. One might wonder how a relatively low-slung animal could pack such impressive weight into its frame. The answer lies in its extraordinary construction. The Ankylosaurus's skeleton was built unlike any other dinosaurs, with dense, compressed bones forming a sturdy foundation for what would become one of nature's most sophisticated armor systems. Recent studies of its bone structure have revealed something fascinating. The bones themselves were uniquely reinforced with internal struts and buttresses, similar to the architectural principles used in modern building construction. This internal reinforcement provided an additional layer of protection beyond just the external armor, making every part of the animal resistant to crushing forces. The Ankylosaurus's skull alone is a marvel of design and intricate functionality. Shaped like a broad triangle, it was designed to withstand immense press. Its jaw mechanics, though less powerful than those of a carnivore, were finely tuned for grinding tough plant material. Juvenile Ankylosaurus specimens, for example, lacked the fully developed armor and tail clubs seen in adults. This vulnerability likely necessitated group behavior during the early stages of life. Trackway fossils suggest juveniles may have formed protective herds, with larger individuals shielding the more vulnerable young in the center. It's a defensive strategy reminiscent of modern musk oxen. As they matured, Ankylosaurus individuals underwent significant lifestyle changes. Adults appear to have been predominantly solitary, a conclusion supported by the rarity of adult specimens found in groups. Their solitary behavior was likely a reflection of their formidable defenses, which allowed them to traverse their environments without fear of predation. Solitary adults might have roamed large territories, primarily in search of food and suitable habitat, avoiding direct competition with other herbivores. Some paleontologists have speculated that Ankylosaurus might have used its tail club for intraspecific communication or dominance disputes. This theory is supported by observations of similar behaviors in modern animals with physical weaponry, such as bighorn sheep or rhinoceroses. The display of their tail clubs combined with body size and posturing could have deterred rivals without escalating into physical conflict. However, the evidence remains inconclusive, and further fossil discoveries may provide clarity on this aspect of their behavior. The coexistence of Ankylosaurus with large herbivores like Triceratops and Edmontosaurus, as well as apex predators like Tyrannosaurus rex, paints a vivid picture of its ecological niche. While Ankylosaurus was not the most numerous dinosaur in its ecosystem, its defensive adaptations end its survival alongside fierce competition. Its very presence in these environments exemplifies nature's ingenuity. I find myself constantly drawn to the ingenuity of nature's designs, especially when it comes to defense. The Ankylosaurus, a herbivorous dinosaur from the late Cretaceous, is a perfect example. Its legacy lives on, not just in fossils, but in our understanding of how animals protect themselves. The Ankylosaurus existed within a finely balanced food web, where each species had a specialized role. Its diet was primarily herbivorous, and it had some amazing adaptations to process tough, fibrous plants. Its broad, low-slung muzzle and simple ridge teeth were perfect for stripping ferns, cycads, and horsetails. Unlike some herbivorous dinosaurs, Ankylosaurus didn't have elaborate dental batteries. Instead, it relied on powerful jaw muscles to break down plant material before swallowing. Recent studies of Ankylosaurus teeth have revealed wear patterns, suggesting a surprising degree of dietary flexibility. While its primary diet consisted of vegetation, It may have occasionally consumed protein-rich fungi or small invertebrates inadvertently gathered while feeding. This opportunistic feeding behavior isn't uncommon among modern herbivores, such as tortoises and iguanas, which sometimes supplement their diets with protein sources. The digestive system of Ankylosaurus likely included a large, complex gut capable of fermenting plant material, which would have been necessary to extract sufficient nutrients from its fibrous diet. Fossilized coprolites attributed to similar herbivorous species suggest the presence of symbiotic gut bacteria, which would have played a crucial role in breaking down cellulose. This process would have produced energy-rich byproducts, allowing Ankylosaurus to maintain its massive body size. I find it fascinating that Ankylosaurus's broad midsection may have been a specialized design to house its extensive digestive system. The large gut volume would have provided ample space for fermentation and nutrient absorption, ensuring the animal could survive on a diet of relatively low-calorie plants. This adaptation, combined with its sturdy build and slow metabolism, likely made Ankylosaurus an efficient grazer, well suited to its environment. The sensory capabilities of Ankylosaurus were as finely tuned as its defensive adaptations. Its most remarkable sensory feature was its highly developed sense of smell, which would have been vital for locating food, avoiding predators, and possibly detecting mates. Fossil evidence reveals that the olfactory bulbs in its brain were unusually large for an herbivorous dinosaur, suggesting that its sense of smell was on par with, or even superior to, that of many modern reptiles and mammals. Recent studies of Ankylosaurus skull fossils using advanced imaging techniques have revealed intricate nasal passages. These passages likely played a dual role, enhancing its olfactory capabilities and aiding in thermoregulation. The convoluted structure of these nasal cavities, which created a larger surface area, may have allowed Ankylosaurus to cool or warm incoming air, helping it adapt to the varied climates of the late Cretaceous period. Vision and hearing also likely contributed to Ankylosaurus's survival. While its eyes were relatively small compared to its massive body, their placement on the sides of its skull would have provided a wide field of view, allowing it to detect predators approaching from almost any direction. This peripheral vision, combined with its heightened sense of smell, would have made it difficult for ambushed predators like Tyrannosaurus rex to catch it off guard. Though direct evidence for its auditory capabilities is sparse, the structure of its inner ear suggests that Ankylosaurus was capable of detecting low-frequency sounds, which could have been useful for sensing the movements of large predators or communicating with others of its kind. One particularly intriguing hypothesis is that Ankylosaurus may have used its sensory abilities in conjunction with its defensive adaptations. For instance, its acute sense of smell and hearing could have allowed it to detect a predator's approach early enough to position itself defensively, presenting its armored back and tail club to the threat. These advanced sensory capabilities underscore the Ankylosaurus as a highly specialized organism, perfectly equipped to navigate its dangerous environment. The Cretaceous period was an era of titans, which produced not only the largest terrestrial predator, but also the largest land animal ever known. It was a true monster mash of epic proportions. While dinosaurs dominated, other species also reached massive sizes, including flying reptiles and marine lizards. Approximately 82 million years ago in North America, the world witnessed the emergence of Deinosuchus, the largest crocodilian in Earth's history. This colossal crocodilian, whose name translates to terrible crocodile, was discovered in the 1850s, when large, distinctive teeth were unearthed in North Carolina. Initially, these teeth were mistaken for those of a pliosaur, a type of marine reptile, leading to considerable confusion among paleontologists. However, they quickly realized that this creature was massive and imposing. The sheer size and unique characteristics of the teeth did not align with known marine reptiles, prompting a deeper investigation. His research revealed that the largest specimens exhibited growth rings in their osteoderms, similar to tree rings, which offered valuable information about their age and growth rates. Some of the largest Riograndensis individuals showed evidence of rapid growth spurts during their juvenile years, followed by more gradual growth into adulthood. These findings underscore the significant impact of environmental factors, such as food availability and climate conditions, on the growth and maximum size of Deinosuchus. With its brain case and overall appearance, Deinosuchus bore a striking resemblance to modern alligators, including a body and snout that superficially mimicked these contemporary relatives. But beyond this general resemblance, Deinosuchus was distinct from other crocodilians, featuring a unique skull shape not seen in any living or extinct genus. The skull of Deinosuchus was exceptionally large, measuring up to 5.6 feet in length, comparable to that of an adult Spinosaurus. Despite its impressive size and robust build, studies have shown that Deinosuchus's bite force was somewhat surprisingly modest. A 2002 study reported a bite force of about 18,000 newtons, sufficient to crush bones, but relatively weak considering its size, especially when compared to the smaller saltwater crocodile, which exerts a bite force of 16,500 newtons. Examinations of Deinosuchus fossils reveal that its skull was not only massive, but also highly specialized. The arrangement of its teeth showcased a combination adapted to its predatory lifestyle: conical and sharp front teeth for grasping prey, and blunt, robust rear teeth designed for crushing bones. This unique dental structure allowed Deinosuchus to tackle a diverse range of prey, from large dinosaurs to hard-shelled turtles, highlighting its versatility as a formidable predator. The bite force of Deinosuchus has been a topic of considerable debate and study, reflecting one of the widest ranges in estimates for any prehistoric predator. Initial research suggested a bite force of around 18,000 newtons, based on the size and structure of its skull. However, this estimate was challenged by a later study, which proposed that Deinosuchus possessed an astonishingly powerful bite force exceeding 100,000 newtons, nearly double that of Tyrannosaurus rex. This dramatic discrepancy highlights the ongoing debate within the paleontological community. Dr. Greg Erickson, leading one of the key studies on this topic, employed advanced biomechanical modeling to simulate Deinosuchus's bite mechanics. Erickson's team found that the robust construction of Deinosuchus's skull and teeth supported the possibility of such a formidable bite force. With 22 exceptionally robust teeth designed to withstand high forces, and some specifically adapted for crushing large bones, this ancient crocodilian was well equipped to exert tremendous prise. These fossilized feces contain fragments of dinosaur bones, fish scales, and turtle shells, providing a snapshot of its varied diet. Dr. Karen Chin, a specialist in coprolite studies, emphasizes the importance of these findings, and I can see why. The diverse prey items found in Deinosuchus remains highlight its opportunistic feeding behavior, suggesting it consumed a wide range of animals, from large herbivorous dinosaurs to smaller aquatic creatures. Deinosuchus is thought to have used ambush tactics to capture its prey, leveraging its massive size and crushing bite to inflict fatal injuries. Like modern crocodiles, it likely employed a death roll maneuver to enhance its hunting efficiency. This technique involves grabbing prey and then rapidly rotating, using its body weight and momentum to incapacitate and dismember it. Reconstructing the hunting methods of Deinosuchus involves analyzing fossil evidence and comparing it with the behavior of modern crocodilians. The robust anatomical features of Deinosuchus, including strong neck muscles and a sturdy body, support this hypothesis, making it a highly effective predator in its ancient ecosystem. What's also remarkable is that Deinosuchus experienced a slow growth rate, as evidenced by growth rings on its osteoderms. These rings indicate that it took around 35 years to reach full size. If Deinosuchus indeed ventured into deeper waters, it might have encountered other giant predators like Tylosaurus, one of the largest mosasaurs. This interaction could suggest a complex predator-prey dynamic within its ecosystem, influencing the behavior and distribution of various species. Deinosuchus lived alongside a vast array of dinosaurs and other prehistoric creatures. It coexisted with herbivorous dinosaurs like Anodontosaurus, Gryosaurus, Cosmoceratops, Utaceratops, and many others. Bite marks on the bones of hadrosaurs and other dinosaurs provide clear evidence of its predatory behavior. Deinosuchus's presence likely impacted the distribution and behavior of these animals, asserting itself as an apex predator in its habitat. Despite its dominance, Deinosuchus vanished from the fossil record around 73 million years ago. The reasons for its extinction remain unclear. Though climate changes, sea level fluctuations, and competition with emerging predators are potential factors, its extinction marked the end of an era. But the fossil remains of Deinosuchus continue to provide valuable insights into the life and ecosystems of the late Cretaceous period. And speaking of apex predators, it always strikes me how, in the world of big cats, the tiger, lion, and jaguar have always fought for supremacy, each vying to be the ultimate predator. But there's one ancient beast that towers above them all: the American lion. This was no ordinary feline. It was the largest to ever walk the earth. Imagine a creature so massive that some individuals weighed as much as an adult brown bear, easily dwarfing today's biggest lions. When paleontologists first unearthed fragments of its skull, they initially believed they had found remains of an unusually large domestic cat, placing it in the genus Felis. This classification, however, would prove to be just the first chapter in a much longer story of scientific discovery and reclassification. As more specimens emerged from the Earth, scientists quickly realized they were dealing with something far more impressive: the sheer size and distinctive features. The American lion. Just the name conjures up images of immense power. But recent science has revealed that this massive predator wasn't exactly what we first thought. Despite its lion-like features, detailed anatomical studies revealed crucial differences, ultimately leading to its reclassification as its own species, Panthera atrox, the cruel panther. These distinctions included a more robust build, proportionally longer limbs, and, most notably, the absence of a prominent mane in males. The sheer size of the American lion really sets it apart from any feline, living or extinct. On average, these beasts were about 25% larger than today's African lions. Male American lions typically weighed between 351 kilograms and 420 kilograms, already substantially larger than any living big cat. But the most impressive specimens, discovered in 2012, have been estimated to weigh an astounding 523 kilograms. That's equivalent to the weight of 8 adult humans combined. What makes the American lion particularly remarkable is that, despite its enormous size, it maintained the agility and speed characteristic of big cats. Conservative estimates suggest it could reach speeds of over 30 mph, faster than any human athlete. This combination of size and speed would have made it an extraordinarily effective predator. The hunting strategy of the American lion likely relied heavily on ambush tactics. Its robust bone structure and powerful muscles would have allowed it to quickly overwhelm large prey. Fossil evidence provides compelling insights. The discovery of Blue Babe, a remarkably preserved steppe bison in Alaska, bears the unmistakable marks of an American lion attack. Deep claw wounds and distinctive bite patterns that match the predator's dentition. Even more telling are the fossils found at sites like Natural Trap Cave in Wyoming, where researchers have uncovered numerous prey species bearing the characteristic damage patterns of American lion predation. What truly set American lions apart from their contemporary rivals wasn't just their size, but their exceptional adaptability and territorial dominance. Studies of fossil deposits across North America have revealed fascinating insights into their social structure and hunting territories. Unlike modern African lions that typically control territories of 100 to 200 square kilometers, evidence suggests that American lions commanded vastly larger ranges, some extending up to 500 square kilometers per pride. The fossil record tells us an intriguing story of their social dynamics. While modern lions live in prides of up to 15 individuals, American lion social groups appear to have been smaller, but more efficient. Bone assemblages suggest groups of 4 to 6 adults working together with devastating effectiveness. Perhaps most fascinating is the evidence of their den sites discovered in caves across the American West. These sites, particularly those found in the Grand Canyon region, show signs of multi-generational use, some caves bearing marks of occupation spanning thousands of years. The walls of these dens often bear deep scoring marks from claws, a behavior seen in modern big cats, but at a scale that dwarfs anything in the present day. Some of these marks are placed over 3 meters high on cave walls, providing tangible evidence of their incredible reaching height when standing on their hind legs. These locations have yielded another surprising discovery. Collections of bones from juvenile American lions of varying ages, suggesting that, like modern lions, they had developed sophisticated parenting strategies. Unlike solitary big cats such as tigers, American lions appear to have invested heavily in cooperative cub rearing, a social adaptation. Cave paintings and archaeological finds hint at the impact these massive cats had on early human cultures, perhaps even influencing early American art and mythology. Then, about 827 years ago, it all ended. The American lion vanished, along with many of North America's large mammals, a casualty of climate change, dwindling prey, and increasing human prey. A combination of factors pushing these magnificent predators past their breaking point. But there was another giant in the sky, a prehistoric ruler with an iron fist, the Quetzalcoatlus. Its shadow must have caused absolute panic. I find myself continually fascinated by Quetzalcoatlus. It possessed this extraordinary metabolism, which fueled its unique way of life. In some ways, it reminded me of other pterosaurs. For a long time, scientists assumed it was cold-blooded, like most reptiles. But now we understand that Quetzalcoatlus was actually warm-blooded and surprisingly active. Warm-blooded or cold, I think we can all agree that Quetzalcoatlus wasn't winning any beauty contests. And, contrary to what some might believe, it's unlikely that any modern flyers are direct descendants of this animal. It had this long, pointed beak, much like a modern stork, but without the hooked tip. Further excavation revealed something quite interesting. The Quetzalcoatlus northrop skull was actually larger than that of Quetzalcoatlus lawsoni, suggesting that northropi was the larger of the two species. One study suggested that Quetzalcoatlus was actually a remarkable flyer, engaging in brief bursts of powered flight before gliding. It could potentially reach a top speed of around 80 miles per hour, sustaining that speed for perhaps 7 to 10 days, giving it an extraordinary flight range. Despite being relatively small in relation to its overall bulk, the torso of Quetzalcoatlus was extremely dense and packed with massive muscles. These giants could have taken off with just a single leap and maintained their altitude with just a few flaps. After that initial launch, they could probably fly non-stop for thousands of kilometers, only flapping occasionally to maintain altitude and adjust their course. Its short wings were made of tightly packed muscle fibers, ensuring both flexibility and strength, allowing for precise adjustments in the air. The extraordinary flight techniques of Quetzalcoatlus even inspired a mission to construct a model flying machine to test flight simulations. The model, roughly the size of Quetzalcoatlus lawsoni, used a basic computer as an autopilot and demonstrated the effectiveness of these flight techniques by soaring and flapping its wings through the air. Interestingly, Quetzalcoatlus and other ashdashids had hind limb proportions more similar to modern running mammals than to their smaller pterosaur cousins, suggesting they were uniquely suited to a terrestrial lifestyle, even though they were quadrupeds when on the ground, like other pterosaurs. All of this has led scientists to study the lifestyle and feeding habits of Quetzalcoatlus in great detail. It's generally accepted that this flying giant was a carnivore, though exactly what it ate has been subject to much speculation. Douglas Lawson, the scientist who first discovered Quetzalcoatlus, initially suggested that it scavenged on the carcasses of sauropods, much like a marabou stork. Scavenging seemed like a plausible option because the fossil was found relatively far from the coast, and there were no signs of large rivers or deep lakes nearby during its lifetime. However, the scavenging idea was later challenged. Scientists pointed out that, unlike the hooked beaks of specialized scavenger birds, the lower jaw of Quetzalcoatlus bent so steeply downward that even when fully closed, a gap remained between it and the upper jaw. This led to the proposal that Quetzalcoatlus might have fed like modern skimmers, cleaving the waves with its beak and snatching fish midair, thanks to its long neck vertebrae and toothless jaws. While this idea of skim feeding gained widespread acceptance for a time, it wasn't scientifically tested until much later. A study revealed that for such a massive flying creature, the energy required for skimming would be prohibitively high due to the considerable drag, making it unlikely that Quetzalcoatlus was a skimmer. A year later, another study suggested that the fossil remains of Azhdarchids were not found close enough to large bodies of water to support the skimming hypothesis. In fact, scientists found evidence that the anatomy of Quetzalcoatlus was quite different from that of any known skimmer. A skimmer's neck is designed to absorb sudden impacts, but fossils have shown that Azhdarchids lacked these adaptations. They would likely have broken their necks simply from the strain of attempting to push their lower jaws through the water. On the contrary, their anatomy is more similar to that of modern storks, suggesting that they most likely pursued and hunted small animals on land. So, for a while, Quetzalcoatlus and its relatives were seen as giant vultures, scavenging the carcasses of dinosaurs and other dead animals. But with time and continued scientific advancements, we are starting to learn more about the actual habitat of this unique creature that once ruled the skies of the late Cretaceous period in North America. Quetzalcoatlus most likely lived in a variety of settings, including coastal regions and inland plains. These enormous landscapes supplied. Imagine walking the earth alongside a creature like Quetzalcoatlus, a solitary hunter, most likely, roaming freely inland. It's a humbling thought, isn't it? Quetzalcoatlus northropi, it seems, wasn't like its relatives.